In this example, we are given an expression that represents the left endpoint approximation of an area under a curve, and we are asked to write it as a definite integral, and we have to provide the upper and lower limit and the function for the expression. So if you recall, this is our definition for the definite integral. And so we're plugging in our endpoints for the rectangles into the function to find the height of the rectangle. That's given by this. I'll label it as h. And then we multiply that by the width of the rectangle. I'll label it as w. And then we have to add up all those areas with the sum. So first of all, we need to identify what our endpoints are. If I look at the expression that's given to us, I see that these are the endpoints. This is what we're plugging into the function. So our xi's, that's 3 plus I minus 1 times 1 over n. Those are our xi's, which means our function, if I take that out and replace it with x's instead of xi's, my function is going to be x to the 6th times cosine of x. So we figured out our function. Now we have to figure out the values for a and b. And we need to use our delta x for that, which is the width of our rectangle. Now, when I look at the expression that's given to me, I see that the width of my rectangle is 1 over n. And in order to find the width of the rectangle, we take the interval, or the length of the interval, I should say, and we divide it by the number of rectangles. So that tells me that I know that my length of my interval is 1. So if I look at my starting value for my xi's, it's 3. And if the length of my interval is 1, then my b must be 4. So to write my final answer, I'm going to write my integral on the interval from 3 to 4. And the function is going to be x to the 6th cosine x, and then I have to write dx. So this is our final answer, which represents that left endpoint approximation of the expression that was given to us in this problem.